Okay, so the first question, the energy level of hydrogen spectrum are shown in the figure. There are some transition A, B, C, D, E. Transition A, B, C respectively represents. Okay, so transition A. So we can see n going from infinity to 1. Okay, so it is basically the series limit. It is series limit of first, we are landing on first level, so it is series limit of Lyman series. Okay, then second B is landing from n equal to 5 to 2, so it is third line, third of Balmer. Okay, and C is landing from 5 to 3, so it is second of Paschen, second of Paschen. So the correct option is C option is correct. Okay, okay, so C option is correct. Okay, now the second, energy level A, B, C, certain atoms corresponding to an increasing value of E. Okay, okay. So in second, we can see E3 is equal to E1 plus E2. Okay, and now we can write it as Hc by lambda 3 equal to 1 Hc by lambda 1 plus Hc by lambda 2. So when we solve this, we get lambda 3 equal to lambda 1, lambda 2 by lambda 1 plus lambda 2. So the correct option is B. Okay, the next question. The figure indicates the energy level diagram of an atom in the origin of 6 spectral lines emission. This. Okay, the following spectral lines below. Okay, so in the third, the absorption is possible from ground state only. So the uh, emission to the ground states will give the absorption. So that's why the line 1, 2, 3 only give that absorption. Okay, 4, 5, 6 will not give that absorption. So the correct option is C. Fourth, identify the incorrect relation. Okay, so the relation between these things. Okay, okay. So the last one, you can see that the potential velocity is given in terms of potential. So we know that half mv square, the kinetic energy gained by the particle, will be equal to potential energy. Okay, so from here the velocity will be equal to root under 2e capital V upon my m. But here the option 4 is V equal to 2ev by m. So fourth option is correct. Like correct answer. Option 4 is correct answer. So fifth electron excited. Okay, so it's direct that the number of spectral lines possible are given by n minus 1 by 2. So when we open the bracket, it becomes n square minus n by 2. So this is the correct option. So C option is correct. 6. In the sixth question, the wavelength of first Balmer series of hydrogen spectrum is lambda. Okay. Calculate the wavelength of first member of Lyman series in the same spectrum. Okay. So we know that we can write the lambda as R 1 by 2 square plus not minus 1 by 3 square. So it comes out to be 5R by 36. Okay. Now for the next one is 1 by lambda dash equal to R 1 by 1 square minus 1 by 2 square. It will give us 3R by 4. And when we solve with these two equations, we'll get lambda dash equal to 5 by 27 times of lambda. That is A option. Option A is correct here. Seventh question, penetrating power of X-ray. Okay, so the penetrating power depends on the acceleration. So that's why first option is correct only. Okay, increase. No, it says that penetration power of X-ray increases with. So if we increase the acceleration, the frequency increases and the penetration power increases. And 8, distance of closest approach when alpha particle of mass m. Okay, so distance of closest approach depending on mass. Okay, so we know that the distance of closest approach is given by 4 kz e square by mv square. Okay, now from here we can see d is inversely proportional to mass. So that's why the correct option will be B option. So ninth question, consider third orbit of helium. Okay, plus using the relativistic, non-relativistic approach. Okay, the speed of electron. Okay. So we have to solve here. So we know that V is given by C by 137 Z by N. Okay, and here Z is equal to 2 and N is 3. Okay, it's given. So when we put the value, we'll get and solve it, we get 1.46 into 10 to power 7. Not 7, it's 1.4. Okay, 1 power 6. So the correct option is C. 10th, in the 10th question, F1 is the frequency of sound, second line of Lemon series. Okay, so let's make some lines. N equal to 1. Okay, N equal to 2. N equal to 3. Okay, so it is F1. This is F2 because frequency is proportional to energy or energy is proportional to frequency. So I can write like this. And this is, let's say, F dash. So I can say F1 should be equal to F2 plus F dash. And that F dash we have to find out. So F dash will be equal to F1 minus F2. So the correct option will be first. A option will be correct. Okay, 11. In 11th question, an alpha particle colliding with one of the electron in gold atom loses. Okay, so alpha particle electron colliding with electron. So we know that the mass of alpha particle is very, very greater than mass of electron. So momentum will not change, and okay, momentum will not affected by the collision. Very less, very, very less. So no, so first and second should not be there. Energy, okay, C option is correct. So energy will be transferred. Okay, most of energy, no, little bit energy will be transferred. So C option is correct. 12th question, the angular momentum of electron in the hydrogen atom is proportional to, okay, in terms of radius. So we know that angular momentum is given by mvr. Okay, now V, the proportion dependency of V on R is given by root under K E square by mr. Okay, we can write this by equating the centripetal force and the electrostatic force. And from here we can see one V is proportional to 1 by root under R. And so angular momentum will be proportional to mass is constant. So for V we can write 1 by root under R, and R is as it is. So I can say L is proportional to root under R. Okay, so the option C is correct here. Okay. 13th, the question 13th says that okay, the 13.6 electron volt energy is required to ionize the hydrogen atom. So okay, then the energy required to remove electron from an equal to. Okay, so we know the energy of hydrogen atom is minus 13.6. Okay, it's talking about hydrogen atom, so I can directly write this is the energy. Okay, and we have to remove the electron from second. Okay, so ionization energy is the energy, total energy. Okay, basically the energy the electron is having in that orbit, we have to provide that energy, then it can be ionized. Okay, so we can say the total energy is the ionization energy. Just the minus and plus sign difference. Okay, minus for total energy, for ionization energy, it will be plus. Okay, so just put the value of n equal to 2. So n equal to 2, we get E2 equal to minus 3.4 electron volt, and this much energy we have to provide to the electron to get ionized. So the correct option is C. Okay, 14th. So 14th question. So it is direct, we can say the size of cesium is very large. So that's why its ionization energy is very low. So the correct answer will be B. So the question of photon with, okay. So for the electron 2 to 1, because in that case energy of photon will be in ground state, the uh, energy is 13.6, and in n equal to 2 state it is 3.4. So the energy of photon will be 10. This okay. Now, so for 15th question, the correct option is B. Okay. The next question, 16. The 16th question, it is saying suppose an electron is attached to the attracted towards the origin by the force. Okay, force is K by R dependence, or we can say K by R. Okay, so electron, and by applying the Bohr orbital system, the radius of nth. Okay, so we have to tell the radius and the kinetic energy dependency of on orbit number. Okay, so orbital number. Okay, okay, okay. N, dependency on n. Okay, we have to find that. So force is equal to K by R. So we can write it equal to mv square by R also. So from here we can say mv square will be equal to K. And if I multiply and divide it by 2 on this side, so it will become kinetic energy. Okay. So 2 times of T, kinetic energy is represented by Tn. So is equal to K. So basically Tn is independent of R. Sorry, N. We can see from here. Okay. Now dependency on the rate of the radius on quantum number. Okay. So let's check that. So we can check that by, we know that angular momentum is given by n h by 2 pi, and that is also equal to mv by r. Okay. So in the above equation, we can see that v does not depends on r, n, sorry, v does not depends on n. So we can say that r is directly proportional to n only. Okay. So the correct option will be B option will be correct. R depends on n, and T is independent of R. 17th question. So in the question 17, the transition from n equal to 4 to n equal to 3 in a hydrogen like atom results in ultraviolet radiation. Infrared radiation will be obtained in the transition. Okay, it's a theory based question, so the correct answer is C. In, when the transition is from 5 to 4 level, then the radiation will have the infrared radiation. Radiation will be infrared. Okay, the photons emitted will have the infrared radiation. So now the 18th question. In the 18th question, it is saying that some energy level of a molecule are shown in the figure. The ratio of the wavelengths. Okay, the wavelength ratio lambda 1 by lambda 2 we have to find. So we know that lambda can be written as hc by delta E, right? Or for magnitude form, we can write lambda, if we divide lambda 1 by lambda 2, that ratio we have to find out. Huh? So for magnitude perspective, we can write hc divided by minus 2e plus e divided by hc minus 4 by 3e plus e. When we solve this, we'll have 1 by 3. So the correct option will be B option. B option will be correct here. Okay. Now, 19th question. The question 19. In this question, the energy required to remove the electron from singly ionized helium atom is 2.2 times the energy required to remove the electron from helium atom. Okay. The total energy required to ionize the helium atom completely is. Okay. In this, it is given that, let's say, E2 is equal to 2.2 times of E1. Okay. And E2 is the energy required to remove the electron from singly ionized. Singly ionized. Okay, so E1, so it is singly ionized. Sorry, not E1, it is E2. Okay. So it is singly ionized. So singly ionized is hydrogen-like atom. So we can calculate the energy by 13.6 Z by n ka whole square. So Z is 2 square 4 and in ground state, so 4. Okay. So it will be 54.4 electron volt. Okay. And if we put the value of E2 in the first equation, we will have E1 that is approximately 24.7 electron volt. Okay. And the total energy for helium atom will be E1 plus E2 to ionize will be, add these two values, will have 79 approximately electron volt. Okay. Yeah, 79 approximately. So the correct answer is B. B option is correct. 20. In the question 20, it is saying that in hydrogen like atom, electron make transition from energy level like with quantum number n to another with quantum number n minus 1, and n is very, very greater than 1. The frequency of radiation emitted is proportional to. Okay. So here the energy of a photon can be written as E2 minus E1, and when we put the value, it will be minus 13.6 by n square minus minus plus 13.6 by n minus 1 whole square. Okay, and put the value, we can take minus 13.6 as common, so it will be minus. And when we solve this, we'll have minus n minus 1 whole square plus n square upon n square n minus 1 whole square. And when we solve this, we'll have the equation 2n minus 1 by n square n minus 1 whole square. Since we know n is very, very greater than 1, so we can neglect this one, and by putting the values, we'll have delta E proportional to 1 by n cube. Okay, let's put the value first. Okay, so we'll have 2 n in numerator it will be n, and in denominator it will be n square. So one n will be cancelled, so we'll have 1 by n cube dependency. So the correct option here is D. D option is correct. Okay. Now let's move to the numerical value type questions. 21. Okay. It is saying the area of electron orbit for ground state of hydrogen atom is A if the area of the electron orbit corresponding to the first excited state is x times of A. Then find the value of x. Okay. So we know the area is given by pi r square. Okay. And we know the r is proportional to n square. So area is proportional to n to power 4. So if we divide A, if we find out A2 by A, if we do A2 by A1, it will be equal to N2 by N1 to power 4. Okay. So it will be N2 is if area corresponding to first excited state. So for first excited state 2 by 1 to power 4. So A2 will be 16 times of A1. So the answer is 16. Okay. X is 16. 22. The energy 24.6 electron volt required to remove the one electron from the neutral helium atom. Okay. Find the energy required to remove the both the electrons. Okay. So we have just calculated, solved this one. Still that we know E1 is given to us for 24.6 electron volt and E2 will be given by 13.6 Z by N whole square. It will be approximately 54.4 electron volt, right? So total energy to ionize helium atom will be E1 plus E2. So it will be approximately 79. Here it is, yeah, 79 electron volt. Okay. Now the next question, 23. The ratio of minimum to maximum wavelength of radiation emitted by electron in ground state of Bohr's hydrogen atom is 3 by x. Okay. Now for the value of x. Okay. So for maximum wavelength, lambda max can be written as r 1 by 1 square minus 1 by 2 square. And from here, lambda max will be 4 by 3r. Okay. And if we write for lambda minimum, it will be r 1 by 1 square minus 1 by infinity square. So it will be lambda minimum 1 by r. When we divide the both, we'll have lambda minimum by lambda maximum 3 by 4. So x is 4. Okay. Now 24. Taking the wavelength of first Balmer line in hydrogen spectrum n equal to 3 to 2 is 660 nanometer. Okay. And for uh, the wavelength of second Balmer line, okay, from n equal to 4 to 2 will be, okay, that we have to find out. So we know that lambda 1 by lambda, let's say lambda 1 can be written as r 1 by 2 square minus 1 by 3 square. So from here, lambda 1 will be equal to 36 by 5r. Okay. Similarly, if we write for lambda 2, it will be r 1 by 2 square minus 1 by 4 square. It will be 16 by 3r. And when we solve both, we'll have this is lambda 2, sorry, lambda 2. Okay. When we solve the both, by dividing, we'll get lambda 2 approximately equal to 489 nanometer. So the correct option, this is the correct answer. Okay. 25. An excited helium plus ion emit two photon in succession with wavelength this and this, okay, in making transition to ground state. The quantum number n, okay, corresponding to its initial state is, okay, we have to find out the initial quantum state, okay, quantum number in, okay, so it emit two photons. So total energy or the total energy of the photons emitted is given by E1 plus E2. Okay, so it can be written as C 1 by lambda 1 plus 1 by lambda 2. And lambda 1, lambda 2 given to us. So when we solve it, we'll have 52.22 electron volt. Okay, so this is the energy of photon emitted. Also, we know that E will be equal to E final minus E initial. Okay, so from here minus 13.6 Z square. Okay, 13.6 Z by NF square plus 13.6 Z by Ni square. And when we put the value of C, NF is ground state, so NF is 1. And Ni we don't know, so we can take Ni equal to N. And we simplify it and we solve it by putting the value of E that we have already calculated, 52.22 electron volt. Okay, so when we solve it, we'll have N equal to 5. So the correct answer is 5. Okay, so 26. The linear momentum of an electron in Bohr orbit of hydrogen atom, principal quantum number n, is proportional to n to power minus x. So find the x. Okay. So linear momentum. So linear momentum we know P equal to mv. Okay. And V is proportional to 1 by n. So P is also proportional to 1 by n. So it will be, we can say P is proportional to n to power minus 1. So x will be equal to 1. Okay. So answer is 1. 27. An electron in hydrogen atom jumps from n equal to 4 to 1. Okay, the momentum. The momentum of the recoiled atom is this. Okay, power we have to find. So when the transition happens, the delta E can be written as 13.6 1 by 1 square minus 1 by 4 square. Okay, and when we solve this, we'll have roughly 13.6 into 15 by 16 electron. Okay, this is the energy of photon emitted. Also, energy of photon can be written as hc by lambda, right? And we know that h by lambda is equal to momentum. So momentum can also be written as delta E by, and delta E we have already calculated by dividing the C. C is, okay, delta is in electron volt. So we have to put the value of E. So let's put it like 13.6 into 15 by 16 into 1.6 into 10 to power minus 19, the whole divided by 3 into 10 to power 8. Okay, when we solve this, we'll have 6.8 into 10 to power minus 27. And the value of x is 27 now, right? So 27, question number 27 is having answer 27. Now the 28. So in question 28, an electron in hydrogen atom jumps from excited state and to the ground state. Okay, and to ground state, the wavelength so emitted illuminates a photosensitive material. Okay, having the work function 2.75. So work function is 2.75 electron volt. The stopping potential of photoelectron. Okay, potential stopping potential V naught is 10 volt. Then find the value of n. Okay, so we know the energy of photon incident on the metal can be given as hc by lambda, and that will be equal to ev naught plus phi naught. Okay, so it will be value, let's put the value, so it will be 10 ev plus 2.75 ev. So from here, okay, so it will be 12.75 ev. Okay, on the other side, hc by lambda is the photon transmitted. Okay, so it can be written as 13.6 1 by 1 square minus 1 by n square. Okay, now we have the equation in which only n is unknown. So by simplifying and solving the equation, we'll get the n equal to 4. Okay, now, and also this side it is in electron volt. Electron volt. The electron volt will be cancelled on the both sides. Now question 29. Question 29. The ionization energy of hydrogen atom is 13.6 electron volt. Hydrogen atom in ground state are excited to them by monochromatic light radiation of photon energy this. Okay, according to Bohr's theory, the spectral line emitted by hydrogen will be. Okay, so we have to calculate the spectral lines emitted. How many spectral lines can be emitted? So the energy of electron in ground state is 13.6 electron volt, and the given energy is 12.1 electron volt. So the rest energy of the electron will be minus 13.6 plus 12.1. So it will be 1 minus 1.5 electron. So this is the energy of electron now. And we know that energy in any excited state is given by minus 13.6 divided by n square, that is minus 1.5. Both are electron volts, so it will be cancelled directly. So n will be 3. And when n is equal to 3, we'll have only 3 spectral lines possible. Okay, let me show you also. This is 1, this is 2nd, and this is 3rd. So 3 spectral lines. Now question 30. So in question 30, if in Rutherford experiment, number of particles scattered at 90-degree angle are x per second. Okay, so number of particles scattered per second at 60-degree angle is nx, so value of n. Okay, so in this question, we know n is inversely proportional to sine to power 4 theta by 2. Okay, when we put the theta, okay, so n2 we can write n2 by n1 is equal to sine to power 4 theta 2 by, sorry, not theta 2, theta 1 by 2 divided by sine power 4 theta 2 by 2. Okay, now n1 is x, and theta, we know theta 1 is 90-degree, theta 2 is 60-degree. So we can find out n2, that will have the n2 equal to 4 times of n1. When we put the value and solve it, we'll have 4 times of n1. So x is equal to 4, not x, n is equal to 4. Okay, number of spectral lines. Okay, n we have to find out now. So nx, right, n equal to 4 we are getting. Okay, I should denote it by capital N. Okay, it might create some problems. So yeah, capital N. Yes. Now small n is 4 times of x. Now question 31. The angular speed of electron in orbit of hydrogen atom is directly proportional, inversely proportional. Okay. So angular speed is given by v by r, right? And v is inversely proportional to n, and r is directly proportional to n square. So when we put the value, omega terms comes out to be 1 by n cube. Okay, so C option is correct, inversely proportional to n cube. Now 32, the magnetic field induction produced at the center of a orbit, okay, due to an electron revolving in nth orbit, okay, is proportional to. The magnetic field at the center is given by mu naught I by 2r, right? And I is given by q by t. Now t is the time period, basically, so time is proportional to r by n. Sorry, not r by n, r by v, because time can be written as 2 pi r upon v. So it's basically r by v dependent. And now we have magnetic field at the center in terms of r and v only. Okay, and we know that r is proportional to n square and v is inversely proportional to 1 by n. When we put the values and simplify it, we'll have p proportional to n to power minus 5. The correct option is B option. Is the correct one. Okay. 33. In which of the following system will the radius of first orbit be minimum? Okay. So the radius in the first orbit will be minimum. So radius is given by is proportional to n square by z. Okay, so just put the values of n and z. We can see that the radius will be minimum in case of doubly ionized lithium. Okay, so in doubly ionized lithium, radius is minimum. Okay, now, okay, one more thing, n is equal to 1 is given. It's z is, no, it's z only. Okay. Yes, so inversely proportional to z, so you can see from here. 30, so the correct option, right? Sorry, the correct option will be WNS, so it is A. 34. 34 is the ratio of the radii of first shell of hydrogen atom and the fourth shell of helium plus ion. Okay, again, we know R is proportional to N square by Z. So R2 by R1, R1 by R2, we can put the values and solve, will have 1:8 answer. So A option will be correct. Okay, just put the values of N and Z, right? Now, 35th question. In 35th question, it is saying that in Bohr model of hydrogen atom, okay, wait, hmm, yes. So in Bohr model of hydrogen atom, the force on electron depends on the principal quantum number as. Okay, so we know force is given by Ke square by R square. Okay, electrostatic force. So R is proportional to N square. So we can see directly from that F is inversely proportional to N to power 4. So B option is correct here. 36. The ratio of ionization energy of Bohr hydrogen atom and Bohr's hydrogen like lithium atom is. So ionization energy is equal to negative of total energy. So basically we can write and ground state we talk about is. So n is equal to 1 and energy is proportional to then 1 by z square. Okay, so whichever is having more z will have less energy. So we can take the ratio for we can write for ratio of hydrogen. Okay, H by He plus will be equal to He plus by ZH whole square. And when put the values and solve, we'll have 1 by 9. Okay, so C option will be correct. Now 37, question 37. So in question 37, what is the angular momentum of electron in Bohr's hydrogen atom whose energy is minus 0.544 electron volt? Okay, so energy is minus 0.544 electron volt, right? And we can write it as minus 13.6 by n square electron volt. By solving this, we'll get n equal to 5. Why we solve this is because now we know angular momentum is nh by 2 pi. So put the value of n, we'll have 5 times of h by 2 pi. The correct answer is C, 38. And 38, the question is the ratio between the total acceleration of electron in singly ionized helium atom and hydrogen atom. Okay, so we know A is proportional to acceleration is proportional to V square by R basically, right? And V is proportional to Z by N, and R is proportional to N square by Z. Simple. So or N is equal to 1, but because both are in ground state, so put the value of N equal to 1, we'll get Z A proportional to Z to power 3. So the ratio acceleration helium plus divided by hydrogen is equal to 8. So correct option is B, right? Okay, and so wait. Okay, now 39. So in question 39, which of the following transition in a hydrogen atom emit photon of highest frequency? So highest frequency will have highest energy, and we know the energy of photon is maximum when the electron transition takes place from n equal to 2 to n equal to 1 only. Okay, because the energy gap between these two uh, levels are very high. That is, and the answer, the energy separation is approximately, I think, 10.2 electron volts. So it will have more frequency then, because energy is proportional to frequency, right? So the option B will be correct. And the last question, 40. In this question, the following diagram indicate the energy level of hydrogen atom when the system moves from 2e to E, a photon wavelength lambda emitted. The wavelength of photon produced during its level to its transition from 4e by 3 to E is, okay. So from 2e to E will have the energy hc by lambda. Okay, so hc by lambda will be equal to E. This is, let's say, first equation. Now from 4e by 3 to E, okay, the energy is hc by lambda dash, and that will be E by 3. Let's say this is second. By solving these two, lambda dash divided by lambda will be 3, and from here lambda dash will be equal to 3 lambda. D option is correct for this. Okay, so for 40, question number 40, the D option is correct.